All right, so let's look at the 6 standard trigonometric functions: sine, cosine, tangent, cotangent, secant, and cosecant. Right. In the last video, I proved that the derivative of sine is cosine and mentioned that a very similar kind of proof can show that the derivative of cosine is negative sine. So let's look at some of these other ones. In order to study these, it's helpful to remember some of the trigonometric identities that relate these functions to one another. So let's start with trying to find the derivative of the tangent function. First thing I want to do is rewrite that tangent function as sine of x divided by cosine of x. So I'm remembering that the tangent is sine over cosine. And now that I've written it that way, we should be able to figure out the derivative using the quotient rule. So let's review the quotient rule. Quotient rule says if you want to do the derivative of f over g, it's going to be f prime g minus f g prime over g squared. Another way to say this is low d high minus high d low all over low squared. Kind of a little sing-song way of remembering it. Low d high minus high d low. I don't know, it doesn't have any tune per se, but that's like the quotient rule, right? So what we want to do here is see our high and our low, right? Sine and cosine respectively. And I know that spelling is silly, and that's not how you spell high and low, but it's just abbreviation. So we want to do the derivative of sine and then times cosine, right? So here's what we want to do. We want to do the derivative, let's do this one. Derivative of sine times cosine, and then minus the original numerator, which is sine, times the derivative of the denominator. So times the derivative of cosine. Then divide that entire thing by the denominator squared, right? So cosine squared. We'll go ahead and write it like that. So now we're going to take what we learned, take what we've already learned about sine and cosine and their derivatives, and those two pieces of information are going to go here and here. So what are we going to get? We have the derivative of sine is cosine. So we have cosine and then times another cosine, right? So cosine times cosine. Minus, and then sine of x times the derivative of cosine, which is negative sine of x. And this is all divided by cosine squared. So let's write that out. This is cosine squared as well. Cosine squared x minus a negative. So those two negatives are going to cancel out and give us plus. And then we have sine times sine, which is sine squared. All right, so now careful, those cosine squareds are not going to cancel because the cosine squared in the numerator is a term, not a factor, right? We're adding, not multiplying, so you can't cancel it with a factor in the denominator. However, what does happen then in the numerator is that cosine squared plus sine squared of x, no matter what x equals, will always be 1. And that is the Pythagorean identity. The Pythagorean identity for trig functions. That's 1 divided by cosine squared. And now we could write that as our answer, but there's a more canonical way to write the derivative of tangent. And it involves saying, well, this 1 is the same as 1 squared, right? 1 equals 1 squared. Pretty sure we can agree. So I could write it like this: 1 over cosine of x, square the whole thing. And the answer then can be written as secant squared. Secant of x squared, because 1 over, and that is since 1 over cosine equals secant. Again, by one of those trigonometric identities that relates the trig function to each other. So that is the canonical answer to the question, what is the derivative of tangent of x? secant squared. Not saying this would be wrong. These would also be correct answers. Even this is technically a correct answer, any of these steps, but the simplified version that we usually use, and you'll see on reference sheets and that sort of thing, is that one. So now, in a very similar kind of way, which I will leave to the viewer to do themselves, you can show, by a similar process, the derivative of cotangent of x is negative cosecant squared. And you can even use the same quotient rule to prove the derivatives of secant of x and cosecant of x. I'll tell you what they are. The derivative of secant is secant times tangent. And the derivative of cosecant is negative cosecant times cotangent. You may see significant patterns among these derivatives here. There are definite patterns here to see. So now we've established all those derivatives. I'm not going to prove any more of them, at least not yet. Later in the chain rule section, I might reprove the secant rule one using the chain rule. You can do it like with the quotient rule, like I said, or you can do it with the chain rule. Just different approaches to the same thing. So I might demonstrate that later, but otherwise I'm not going to provide proofs for the rest of these. What I'd like you to do is memorize all of these. These, pretty much all of these should be memorized. The ones we use most often are the first three, sine, cosine, tangent, but I want you to have these memorized as well for tests and the like. That's it.